Okay, so we're going to start factoring polynomials today. And the thing about factoring polynomials is it has to do with what we did last week when we were multiplying because of the distributive property. So looking at this first example, when you multiplied last week, you would say 3 times A plus 3 times B gives me 3A plus 3B. Okay. So what we're doing today is we're saying, hey, you have 3A plus 3B. What is the greatest common factor? 3. And you're going to factor that out, and you leave in parentheses A plus B. So whereas we've been distributing when we were multiplying, you might think of what we're doing now as undistributing. Forwards and backwards. Almost like division, but the number doesn't disappear. It's still there. So when you would distribute your x, you would get xy minus xz. But when we look at this, we say, hey, what's our common factor? X. So we would take out our x and leave in y minus z to our parentheses. We could do that with a monomial. So distribute the 6y. They give us our intermediate step, and then they simplify. So if I'm looking at 12xy plus 6y, what is my GCF? 6y, because 6y was distributed here. So 6 is our greatest common factor of our coefficients, 12 and 6. 6 fits into both of those, but also both terms have a y, so I can factor that out. And when I do that, I'm left with 2x plus 1 in parentheses. So if what you're factoring out is the entirety of a single term, then you have to leave behind 1. So we're going to go over some very important examples to try and let you see things. Not everything will be like 6y. We might be able to factor out a y to the 5th power, or xy squared. So it's going to be important to look at those things. So let's start off baby steps. Number 1, what is our greatest common factor? What do you think? 24. So 24 fits into 24 and 48. So what would be my first term if I factor out a 24? 24x would just be x. Think about it. Remember, you're undistributing. So what 24x, 24 times what equals 24x? So plus, what would be my second term? 2y. So I like to take it in baby steps. I like to say, looking at my coefficient, what is my greatest common factor? What are my coefficients in this trinomial? 30 and negative 6. So what's my common factor? 1. So should I factor out any coefficient? No. Then I'd look at my variables. I say, oh, here's an m. Oh, here's an m squared. But do I have an m here? So can I factor out an m? No. Okay, and then I look at the p's. P squared, p, p. Can I factor out a p? Yes, because it is common amongst all the terms. So p, and then we have 30mp plus m squared minus 6. Okay, let's talk about number 3. What's the GCF here?
2.
Do we have a 2 here?
No.
1. So if they do not share a common factor except for 1, then we call it unfactorable. Or remember, if something only has the factors of 1 in itself, it could be called prime. You may also just see not factorable as an option. Any questions on that? Now, number 4 is an example that I want us to see because it will have everything to do with what we're doing tomorrow. Here is our first term. Here is our second term. what is their common factor? Y plus 3. This whole thing is being multiplied by x, and this whole thing is being multiplied by 5, and since it's in both terms, we would say it is our common factor. So if that's our common factor here, what is my other what's my other factor? What's left behind in parentheses? X plus 5. And this has everything to do. Remember that factoring is just backwards multiplication of polynomials? So looking at your examples from last Monday, 1 week ago, we distributed the first term, the first binomial, each term got distributed to the second part. So this is basically saying, okay, let's go backwards. I see x plus 7 in both of these. It is one term, and 3x minus 1 is the second term. Okay. So I see a couple blank stares, so look on the back right there. On number 1, what is the common factor? Y plus 1. So what is left in parentheses? X plus 2. Okay. On number 2, what's my common factor? What's left in parentheses? Okay. All right, number 5. What do you think about number 5? Unfactorable, prime. Number 6. 7 is my common factor of my coefficients, but it also has x in both terms. So then we have x plus 2 left in parentheses. Yes? Okay, back over to this side. Let's look at number 12. Remember I said let's take baby steps. Look at the coefficient. My coefficient of 40, my coefficient of 16. What's the common factor? 8. Now look at our x's. We have x to the 8th and x to the 9th. What is my common factor? X to the 8th. And I have y to the 6th, y to the 5th. What's my common factor? Y to the 5th. And you can see this when we think, okay, here's my result. This is what I want to get to. 8 times what gives me 40? X to the 8th times, I don't need to multiply it times anything to get x to the 8th, so I don't write anything here. Y to the 5th, what do I need to multiply it by to get y to the 6th? Y. Minus 8 times what gives me 16? X to the 8th times what gives me x to the 9th? And y to the 5th times, y to the 5th to y to the 5th doesn't need anything. So sometimes your greatest common factor has exponents, and that's okay. All right. Any questions about anything we've done so far?
I'm confused how you got the 8x to +6.
So we said, what is the common factor? 40 and 16 are both divisible by 8. X to the 8th and x to the 9th are both divisible by x to the 8th. When I divide x to the 8th by x to the 8th, I get 1, so it cancels out. But if I divided x to the 9th by x to the 8th, I would just be left with x. Y to the 6th and y to the 5th are both divisible by y to the 5th. Y to the 6th divided by y to the 5th leaves y. Y to the 5th divided by y to the 5th cancels out. So remember, you're going backwards. You could check your answer by mentally distributing in your mind. You'd say, okay, I'm going to multiply this times my first term, I'm going to multiply this by my second term. But you wouldn't write out that answer because that would be how you started. So you're just checking to make sure that you've gotten your common factors all squared away. Okay, try 2 minutes, take these 7, 8, and 9. Okay, let's check your answers. Number 7, what is your greatest common factor? 7t to the third. And so when I factor out 7t to the third, what's my first term here? 2 minus 6t to the second power minus 7t. Okay, what is our greatest common factor on number 8? And just to show you, I can write parentheses if I want. 11 what? 11p squared. And that would leave what? 5 minus plus 5 minus p squared plus 4p to the third. Number 9, what is my greatest common factor?
7.
Why? Why is there no 7? 7 fits in 14, 7 fits into 28. Why no 7? Because the last term does not have a coefficient. Or it does, but it's just 1. So 14y squared minus 28y plus what? 1. You've got to have that third term. If you're like, oh, I divided by 1, it cancels out. However, I divided by y divided by y cancels out. However, if you thought about going forward and you distributed the y, then you would be left with a binomial and not a trinomial. So you've got to have that 1. Okay, before you get started on today's classwork, I just do want to show you some things about what I would prefer. If you see a negative, I would prefer, if your leading coefficient is a negative, that you factor out a negative. So normally you look at these and you would say, oh, 8. But because all of these are negative, I would prefer you factor out a negative 8. Now, when we start tomorrow, it will start to make sense when you need to factor out a negative. And when we do trinomials, you won't have an option. It'll be very obvious whether you have to factor out a positive 8 or a negative 8. But for today's purpose, I would prefer you factor out a negative if the leading coefficient is negative. However, looking down at number 9 on your homework, both of these answers are correct. I prefer the second one. However, the first one is still full credit. Do you understand?